Welcome to Unit 5, Lesson 3, Understanding Rational Inputs Practice Problems. Select all solutions. Okay, let's go. M times M equals M cubed. I should put another hump on there. Equals 104. We have to take the cube root to get rid of the cube, not the square root, the cubed root. M equals the cube root of 104. So, that is F. It is also equal to, if I put our exponent here, 104, because the base stays the base, to the 1/3 power, which is also E. Okay, and the pond that is covered by algae doubles, okay, doubles each week. So our B is 2, our X stands for week. You have to figure out what's going on in the situation, understand your units, and then write your equation. When the algae is first spotted, the area cover is 12.5 square meters. So 12.5 doubles each week. So 12.5 doubles, and to the X power, this is each week. So this is my original equation. Let's see what they ask us. Now, explain why we can find the area of algae covered one day after it was spotted. 1 day by the 7 to the root 2, the 7th root of 2. Okay, so 12.5 change 2 to the 1/7 power. So what is 1 week? 1 week equals what? 1 week equals 7 days. So if we divide by 7, 1/7 of a week equals 1 day. So if I take my X and I divide it by 7, this is going to give me an output of days, the algae coverage by day. Okay, this is a good unit, not by the week, but by the day. Okay, find the area in square meters covered by the algae 10 days after it's spotted. So I'm going to take my equation, y equals, I'm going to put this into the calculator. We started with 12.5. It doubles every week, but we had X out of 7, which is going to give us 7 days. 1 day, I'm sorry. If you divide week by 7, you'll get 1 day. So now, when I put this into the calculator and the y equals, when X equals 10, what is Y? So if when X is 0 is 12.5, in 1 day it should have doubled to 25. So it should be a little bit more than 25. And Y is about 33, I'm rounding to 33.65. Okay, so 0 was 12.5. 1 day was 25 because it's doubling. And then 2 days it would have went to 50 by looking at the numbers in the calculator. So 10 days is 3. So it's more than 25. So that's a good number. Okay, so let's see what's going on. This function, 3/4 represents the mass material left in milligrams. So 75% of is left. It's losing 25%. Because 3/4 of 100, or hour. So 3/4 of an hour. No, 3/4 of the amount in an hour. So if H equals 1 hour, if I divide an hour by 2, I get half an hour, or times it by 0.5. So what does M of 0.5 represent? It represents how much is left in 1/2 hour. So now what I'm going to do is rewrite the equation, 300 to 3/4 to H over 2, and I can calculate what the actual amount is in 1/2 hour when I do this. Y equals 300, parenthesis, 3 divided by 4, close it, x divided by 2. Second graph. So, in 1 point of time, I get m of 0.5 is equal to, what's that? 259.8. 259.8. Oh, look, they gave us a graph. All right, so in 1 hour, we were here, and we wanted to calculate 1/2 hour. Oh, look at this. This is broken up into halves. So, in a half, we were there. And so what did I say? 259, close to 260. That is 300, 250. So this is 275 right here. So yeah, I guess that looks about right, in between 250 and 275. Looks closer to 250 though, but close enough. Coming down. This is 1/2. That's 1 full hour. Half an hour is 30 minutes. I would have went with a different time frame, but whatever. Okay. Now, suppose the material is measured at noon. So we had 300 whatever milligrams of whatever at 12 p.m. and 4:30. Since I'm already in half-hour jumps, how many jumps to get to 4:30? So at 12, 12:30, 1, 1:30, 2, 2:30, 3, 3:30, 4, 4:30. So 12 is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. So when x equals 9, what is y? Y equals what? So all I got to do is scroll down to 9, and I see I got 82.2 left. All right, the area covered by a lake is 11 square kilometers. It is decreasing exponentially at a rate of 2% each year and can be modeled by this. All right, so this is what's left. 98 represents what is left. So it's losing 2% each year. Okay, A, area as a function of time. By what factor does the area decrease in 10 years? What does T stand for? T stands for each year. So all I got to do is put 0.98 to the 10th power. That's the factor. And by what factor does it increase each month? Each month. So I'm going to take 0.98. T stands for year. How many months in a year? 12. So if I divide T by 12, I can get the factor each month. What I can also do is take the 12th root of 0.98, because that's the same as what we did in the warm-up today and yesterday. And I can do this. And that will also give me the same number, because it's the same thing. So these are just the factors. They didn't ask us what the area was. They're just asking us for the factor. And the whole factor is the growth rate times the time, times the exponent. Sequence of numbers is increasing exponentially. That's also geometrically, which means we're multiplying the same number to each term. So how do we go from 100 to 500? We times 5. To figure out going left, we have to times it by 1/5 or divide it by 5. So 100 divided by 5 is 20, divided by 5 is 4. Okay, the population of a city is modeled by a function where T is the number of years after 1950. So this 250 does not mean 250. This means 250,000, because that's what this means. So whatever number we get, we're going to have to multiply it by 1,000 if we're asking us for numbers. So be careful. We want to get this a lot because people make math errors with calculators. So when things are in the thousands or the millions, they just give you the first three numbers or the first couple of numbers, and then you have to multiply by a million at the end. It's much easier to work with in the middle of the problem. Where T is the number of years. So we had 250,000 in 1950. The population and, all right, so which of the statements are true for the model? All right, 250,000, 1.01. All right, so let's go through the equation. So A equals 200, let's put this down here, I'm sorry, because there's no room up here. It's going to get janky. A equals 250,000 in 1950. That's our start. B is 1.01, which means there's a plus 0.01 or 1% increase each year. And T equals 1 year. So that's what you read in the problem. So which statements are true? So the population in 1950 was 250, not 250, 250,000. The population grew by 1% each year. And then the population in 1951 was 275,000. The population does grow exponentially, but we can put it in the calculator into y equals. I'm going to put 250 parenthesis 1.01, close it, caret x, second graph it, and then we see in year one it was 252,500, not 275. So A, B, C, and E are the ones that work.